And this is why.
Okay, inscribing figures.
I don't want to finish the sentence.
A circle has what degrees?
360.
360. So,
2.
we're going to talk about some inscribed things, okay? An inscribed angle and an intercepted arc. An inscribed angle has a measure of 1/2 of its intercepted arc. So the measure of angle ADB equals 1/2 the measure of arc AB. Now, when it is a central angle, what do you know about the angle and the arc?
We're all right.
That's the one we're talking about?
No.
What do you ask?
When you have a central angle,
That's the same as the arc.
it's the same as the arc.
Because I asked you.
Yep, good. It's the same as the arc. So if my angle goes through the center of my circle, like at the center point, then the arc and the angle are the same measurement. If my angle is inscribed inside of my circle, see how it hits the outside circumference of my circle? Then it is half of what my arc is. So if arc AB is 68 degrees, what is the measure of angle ADB?
132.
No.
Sorry, can you repeat the
If
question?
arc AB
How many degrees?
is 68 degrees, what is the measure of angle ADB?
34.
34. The angle is half of the arc, which makes sense because look at this. Does this look smaller than this?
Yes.
Yeah.
Yes. So my arc is 68, then this angle is
I read that
34. Okay.
I can taste the yummy G. Way better than my apples.
Now, the next part says this. Inscribed angles and same arc theorem. If two inscribed angles intercept the same arc, then the angles are congruent. So see how angle ABE and angle ADE intercept this same arc of AE?
Yes.
Then they're congruent, which makes sense because they're half of what the arc is, correct?
Yes.
So if the angles intercept the same arc, then the angles are congruent. So if I know that angle ADE is 42 degrees, what is angle ABE?
42.
42. And what would arc AE be?
84.
84. So you can solve any of this stuff, okay? I know, mind blowing, really.
Looks like a W.
Okay.
Not good.
That means that I can put shapes inside of circles. Okay, inscribed quadrilateral theorem. What's a quadrilateral? Four-sided figure. So any four-sided figure can be inscribed inside of a circle, okay? A quadrilateral can be inscribed inside a circle if and only if its opposite angles are supplementary. And supplementary means
More than 90.
add to 180. Add to 180. So if angle A and angle D equal 180, and angle B and angle E equal 180, then I can put it inside of a circle. If the opposite angles are supplementary. Okay? The opposite angles are supplementary. Then you have the Silic quadrilateral inscribed angles theorem. The inscribed angle formed by one diagonal and side of a Silic quadrilateral is congruent to the inscribed angle formed by the other diagonal and opposite side. Meaning this. This is a diagonal, correct? Okay? So if I create this diagonal, look at what shapes I can create.
Triangle.
Triangles, yes? Now, that's good news. Because that means that ABCD, the measure of angle ABD, is congruent to the measure of angle ACD. So ABD, this angle right here, would be congruent to ACD, this angle right here. Because what I'm doing with those diagonals is what? What are you doing with those diagonals?
You're making
One second, I'm
lines.
ready.
Back in here.
No. What do you do when you draw those diagonals? You do what with the angles that they go through?
Cut them in half.
Uh-huh, okay. And if I know that B and D have to add to be 180, and I know that A and C have to add to be 180, correct? Then when I cut them in half, I
Or
get
90.
Complementary angles.
That's not what I meant. I feel like I didn't say that.
no. And when I cut them in half with these diagonals, I then create these triangles, which I can prove are either similar or congruent depending on what shape, what exact angle measurements are. Okay?
How can I pare this down? What's like short way to say it?
The thing at the bottom?
The description.
The thing at the bottom.
Miss Peters.
What?
Is there a short way I can?
No.
There's
But from the bottom?
You just know that the angle, it's basically like, when the diagonals happen, the two angles that are like, sort of parallel to each other, I don't wanna use parallel because they're not exactly parallel, but the two angles on top or the two angles on bottom would be congruent to each other depending on how you drew your diagonals.
I'll
Okay.
just do the picture and understand.
Martin.
No.
Guys,
What?
you can have 10 more seconds.
That's all I
Thank
need.
you. Thank you so much. Just go apple. I can plant a tree. For those students.
I bet it was wrong.
They're gonna go plant a tree. I'm gonna plant a
I
tree.
got it, little girl.
No, I could like.
Honestly, the picture explains everything. That's
What did I say?
That's fine.
What did I say? You look at the, you're eating a full apple.
Yeah, she is.
You don't see it.
Okay. Inscribed right triangle theorem. Inscribed right triangle theorem, okay? A side of an inscribed triangle is a diameter. Boom.
Wow.
Like this right here is my diameter. So whenever you put a triangle, a right triangle inside of a circle, one of the sides is its diameter, period. You can't put a right, you can't put a right triangle
Period.
inside of a circle without it being a diameter length, okay? If and only if the triangle is a right triangle with its right angle opposite the diameter.
Whoa,
Boom,
crazy.
parallel to.
So JL is a diameter if and only if triangle JKL is a right triangle with its right angle opposite of JL.
I love math. Actually, I don't.
Yeah, take it.
I take it back. Sorry.
Math was fun until seventh grade.
I love the
I
math
don't
makes
know,
sense
actually.
though.
Math was fun until freshman year.
It's like I love math.
The class was fun.
Algebra was fun.
If it
I
only
know.
was
It was
the
fun.
right
Geometry, not so much fun.
No, geometry's way better than algebra because algebra you can memorize stuff.
Well, I like algebra
Yeah,
way
that's
better.
right.
I like algebra way
What do you
better.
mean?
That's
It's
because
the
y'all
same
did
thing.
better in
And
algebra.
my
I do better
last
in
test
geometry.
grade does
Wait.
not represent that. But we're not gonna.
Oh my gosh, I still need
I'm doing much better in this class.
I just need an apple tree, guys.
Oh, that's, I see exactly.
Is
Yeah,
better one.
yeah, you
It's
got me stupid.
I understood it.
Okay.
I was trying to talk. Can I have an apple?
Algebra was,
I don't
I starved.
care.
algebra was goated.
It was so much
Because
fun.
you
My
didn't
class
bring
was so
one and
fun.
that's on you.
I made my own.
And people try to give you food and you wanna
I
take it off.
did. I
I do that every day.
Wait, where did we come from? Did they come in here for lunch?
No, Miss Peter
Because I
sat
forgot to do it last time.
downstairs.
And I wasn't there. I was working on my English paper that I did. Oh, we're on film. Yeah, I did not finish that during class, Mrs. Akira.
I don't think
She
it's.
watched
Okay.
all of it.
Yeah.
Let us talk a little bit here. Let's talk about some scenarios and see what we can come up with, okay? This is a circumscribed angle right here. This is called circumscribed, okay? Do you notice how the angle has two tangent lines that create it, correct? Okay? So it is a circumscribed angle. Honey, you might want to draw this down. Okay, circumscribed angle. This right here, which we've talked about already, is a central angle, meaning that the angle happens through the center of the circle, yes? And then what we just talked about today was an inscribed angle, where my angle hits, sorry, the circumference of the circle someplace, yes? So we're gonna have three types of angles we look at with arcs and circles. A circumscribed angle, a central angle, and an inscribed angle. Central and inscribed, explain what they are. So you should be able to figure out which one's circumscribed, okay? Because the circle is inside of that angle, is what's happening, okay?
Nice.
Circumscribed angle, central angle, inscribed angle. Inscribed angle means the angle is inside the circle.
Is it always gonna be on that, on like, from a point on the outside?
You mean like this?
Yeah, like.
It has to touch the circumference, yes.
Okay.
Central angle means it hits the center, and a circumscribed angle means that the circle is inside of the angle itself.
Cool.
So you get,
An inscribed angle and its intercepted arc theorem, okay? Inscribed angle, intercepted arc, we just went over that, what does it tell me?
Wait,
Yes.
An inscribed angle has a
No,
measure,
tell me from what we went over
Okay.
earlier, give me an example.
so
If the angle, if the arc is what?
if the arc is 42 degrees,
Okay.
then the inscribed angle is going to be 21 degrees.
Beautiful, so
Good
it's
job, Peyton.
half of what the arc is.
yeah, we wrote it
Yes,
down, you
we're
know,
going over all of them again.
they just drew them in
I was
color.
like, I feel like I've written this down.
Cause
Okay.
these are from the video.
Inscribed angles, remember this is the same thing, inscribed angles. If two angles are inscribed, correct, and they share the same arc, what happens?
They're congruent.
They're congruent, the inscribed angles are congruent. Right triangles, now this gives us a problem to do.
Yay!
This
yay.
right triangle is inscribed inside of a circle.
Yeah.
What is YZ?
The
circumference of this circle, C is 8 pi.
So you have to do 8 pi and then divide by 2, right? What, I just need to
How do you find the circumference of a circle?
8,
Pi r
2
squared.
pi r squared.
Pi r squared?
no,
That's
one,
weird.
2 pi r.
2 pi r. No.
Is it 2
It's-
pi r?
One's area and one's circumference.
Two
Oh, 2 pi r.
r.
It's 2 pi.
2 pi r.
Guys, that was me. Oh my gosh, I feel
So
so
2 pi r equals circumference, and you know that the
go
circumference
again.
is
8 pi.
8 pi, okay?
Oh, I need you to.
So I need to figure out what YZ is, so what do you need to do to 8 pi?
Find the radius.
You've already been
Okay, how
doing
do you
it
do
wrong.
that?
I have-
Do 8 pi.
I'm aware.
What do you divide
You
by?
do-
What?
2 pi r?
What do you
No, I
mean
have
divide?
That you need to make. I already
Look.
know it.
This formula says 2 pi r equals circumference, yes?
X.
8 pi equals circumference.
Oh, you just
That
said by
means
2
the radius is
pi.
four.
Divide by
2
2 pi, thank you. And your radius equals,
4.
so what is xy? Or what is yz, I mean? It's what? 8
Eight.
because it's the diameter.
Oh, that was
Who
easier than
would
I
have
thought.
What's the answer?
known?
Easier than I
I'm gonna
thought.
write that down.
Thank you.
Or
Oregano.
if you really want it to be,
The diameter.
remember circumference is 2 pi r or pi times
Pi diameter.
d, so you could have just divided by
Yeah.
2
pi.
2 pi.
You could have.
by pi.
But
got
it
it.
didn't.
Okay. Now. Oh yeah, I got it. Okay. Let's look at a couple other problems I'm gonna put on the board.
Yeah, I need some more problems.
Okay, we're gonna go like this. Here's a circle.
I love circles. They are so perfect and no, nothing wrong with them.
And here, Q, U,
Q.
QY.
Rule number 1, if it's about
A, B, C.
guys, shut it.
take it. Abby, what is your
Guys,
favorite number of the letter?
stop talking. What do you not comprehend about that?
What does that mean?
Stop. Okay, you have an inscribed trapezoid inside of a circle, correct? Okay, and I want to know what is the measure of angle A?
Angle
Angle A.
Okay.
Ooh, I know.
What?
You gotta add the 2 and divide.
What do you mean add the two? Give me more. I
70, 96, and 52.
why am I adding 96 and 52?
Because they're part of it.
It's the arc. And the the
Yeah.
angle thing is half of the arc. So 96 plus 52 is, wait, no, Chloe's got this. Guys, do not even
So
fret.
A
148.
encompasses the arc that is
Yeah.
DQU, yes?
So it's
74.
72.
So it's
74.
96 plus 52 divided
74.
by
It's 74.
2.
I wonder who
Really
said
good
that.
work. My guy's on fire.
74.
That's crazy.
Yeah.
So measure of angle A is 74 degrees. You're gonna have problems like that tonight.
That's kind of fun. This chapter is way easier than I
Okay.
thought.
So what would be the measure of angle D?
152, 50, 25, 75.
I know y'all did not
76.
just pull out your calculator
D
to
is
figure
here.
that out.
It's 76.
I can't think.
And you're looking here, yes?
I don't do division in my head.
52 plus 100 over 2, right?
76.
Okay.
Okay?
Okay.
Okay? So you're gonna have problems that look like that tonight. Got it?
Okay.
Okay, now let's talk about something else. Let's say that you have this. Let's give you another circle.
Okay.
And let's shut it. Okay, let's say here is this DC. Here is this AB. Okay, and let's say that this is 45 degrees. Let's say that this is 82 degrees, okay? Let's say that this arc is 35 degrees, this portion right here, okay?
Arc ABC equals like
I wanna know what the measure of arc AB is.
arc AB.
Okay,
Uh,
okay. This is what we have to do, right?
35. No, it's not.
So we know that,
Brandon, bring.
what were we doing? AB.
I wanna know the measure of arc AB.
So you have, wait, arc AB, okay, so arc AB is
I
half
can't even
of,
think when these people are talking.
I know.
it, sorry, I just talk a lot.
Ah,
We know.
Oh, you're processing about this though, so it's okay.
Wait,
Is
no,
it
but it's not,
35?
it's not an angle thing, it's a square,
It's a 35.
it's a square fit, no, yes. Oh yeah, it's just 35.
Is it
So,
35?
I don't know.
no, I know it's not. So,
What do you know? Let's start with this. Is there an angle that is inscribed that goes with that arc?
No. D?
Yes,
But
there
yes,
is.
there
Is it D? Or is it C? Or is it half of C? Well, if you're blind, just open your eyes.
yeah. that's
You're
what
gonna
I'm
have to
saying.
do several steps on this.
Yeah.
Okay, so
That
we
right there is
know
offensive.
that, they have to be supplementary, so they have to add up, right? Don't they, don't,
If there's 4 sides, then divide by 4.
so, basically, we subtract.
106.
We subtract 180
Oh.
from 45 from 180, right? And to get the other angle, and then
No.
subtract. Really?
You have to add 45 and 82.
Listen, stop, just stop.
Okay.
This circle is made up of how many arcs currently?
4.
4. 1, 2, 3, 4. We know that this is 35. Why don't we try finding another arc to start with? Like maybe since this is cut like this, we can figure out what that arc is.
That's what I was thinking.
No, you are.
No, it's not.
It is 180 minus 82, right?
It's what?
Or
No.
no, aren't they have to be supplementary?
If I wanna find, let's figure out what arc BC is.
Is it 90?
Yes, how did you get that?
Because the diagonal, the 82 would go with C because it's the
What?
diagonal theorem thing, the Sicilic quadrilateral thing.
What's
Okay.
that?
And then so it would be.
So you're saying
opposite.
it's with, well, time out. You're saying 82 goes with C, but what, like the whole C or
No, like half of it,
which half?
the top. No.
I thought that
I
B
don't
and
know.
D went together and A and C went together.
Yeah.
What? Okay, wait, repeat what you just
I
said
thought
to
that
me.
it was
Abby.
from
Back to biology.
Me? No, this one.
A and T.
Repeat what you just said.
I thought that A went with C and B went with D.
What do you mean A
So-
goes with C?
Like the 45, because of the kind of parallel thing that you explained to me.
Okay.
Like the 45 would be part of C.
You
I
think
still
it's
think
part
it's
of C?
106.
Yeah,
Okay, so let's
because
think.
it doesn't make sense for it to be part of D. because
Time
the
out, let's think
diagonals
about
are-
this. There's another way to solve this. What's 45 plus 82?
127.
120.
And what's 180 minus 127?
53, so 106, and that's what I said.
Stop, it's not 106.
No.
So this is 53, yes?
And the other one's
Which means
127.
this is what?
53.
127.
So why do you think that's 53?
Because vertical angles.
Okay,
Oh,
which
no,
makes
no, no.
this what?
127. And 127.
Which makes this what?
But with like.
But 80 from
53.
45.
Can you tell?
45.
45.
You just put the portion.
No, it has to be.
No, it's 127. BC is 127,
Oh my
right?
gosh, y'all freaking out.
No, it's not.
Guys,
No.
stop
Stop this.
and listen. No, BC is not 127. This is not the center of the circle,
Why?
Because it's not.
because it would definitely be like over here.
Yeah, like, look.
Okay, it's not a central angle. Nowhere does it say that that's a central angle, and you would know it's the center of the circle
because
because it would
53.
have a dot and it would show that that's the center.
And DC would be 53, not 35. Sorry. Got confused there.
Correct.
With my
So,
dyslexia.
we've kind of started something here, but now we have to figure out how to finish this. Okay, so you know that that's 127.53. Now we're arguing about something being 45 and something being 82, yes?
I suppose.
Okay, do you know if any of those are actual right angles, A, B, C, or D?
No.
No, so you can't assume anything. Okay,
Could we assume that the B, the center point of that figure, and C, that triangle, is isosceles?
no,
Okay.
why would you say that?
I was just trying to think of something.
Okay.
Good job, Caleb.
Oh, can we be totally honest?
Okay,
guys?
listen, let me tell you what you need to be looking at and see if you can think from here.
I still
You
think
need to
it's
be looking at all, you need to find all the other, you need to find the two other arcs so that you can add all three together and subtract them from 360.
So,
So how can you find arc BC?
So we need to find what angle goes with which arc, and then you can do your thing.
How can you find arc BC? Or how could you find, what do you know about arc BC? That it's what?
The big one.
I think it's 254.
Look,
that doesn't make
look
any
at what we have to work with. You have this to work with, yes?
Yes.
C.
Look at this. If I go from here down to here,
Oh.
and I go here to here, what happens?
It's a triangle.
No,
It's an
stop.
angle.
It's an
It's an
angle
angle.
with
Oh,
what
it's
as
the
its
inside
intercept arc.
angle.
Yes, with
And
what?
it's
That's 90
90.
degrees.
It's 90.
I've been like.
Guys, we were so, and then the other one
You
was 82 plus 82 was
How
82
about
plus 92.
Yes.
I told this calculator.
So then, Chloe, what is this arc?
82 plus 82.
Which is?
164.
So then what do you need to do?
Add them up to and subtract from
What's
360.
164, 90, and 35 together?
Somebody smart, can you do that, please? Wait,
289.
190.
289.
And then 360 minus that?
It is
90.
71.
It is what?
71.
That is
Oh my
the correct
goodness, what
answer.
the-
Yay, guys, good job. Clap for
Now
yourself.
listen, this right here that you just had me do,
How's
that
that
you guys were
106?
thinking about doing is unnecessary, because you have to start being able to see that this intercepts that arc as well as the fact that other things do. You get what I'm saying here? Okay, you gotta start looking at that, what, Abby?
So what was the thing with the
Whoa.
the one thing where the diagonals or no.
Yeah, because I saw
That doesn't apply here, you're trying
What
to do
is
too
it?
much.
Don't do that.
No,
Like the
Abby, what are you
parallel
talking
things
about?
and the supplementary angles and
That's not what all is in there, that is not it at all.
Well,
It says, stop,
So much.
I don't get it.
it says that when you have two diagonals,
Mhm.
okay, the inscribed angle formed by one diagonal and side of a quadrilateral, okay, quadrilateral that's not a perfect quadrilateral is what that means, okay, is congruent to the inscribed angle formed by the other diagonal and the opposite side. So when they cross, then those two outside angles on the top part become congruent to each other, okay? It can't be it can't be a square, it can't be a rectangle, because that wouldn't work, because it would divide it into 45 and 45, so it's different than what it's saying, okay? These are the things you gotta start paying attention to and looking at: triangles, angles that are inscribed, angles that are in the central, and angles that are circumscribed. okay? You gotta start paying attention to what you're working with. You could work with all of them in one setting, okay? It might change. You need to try to figure out what is it, and I would suggest color coding things.